We're going to be running a server-side request forgery attack. The idea behind server-side request forgery is that we manipulate a server into sending a HTTP request on our behalf. So technically, we are the origin of that HTTP request, but it looks as if that HTTP request originated from the server. As a result, the recipient may elect to trust that HTTP request because it appears to originate from the server when in fact it originates with us, the attacker. We're going to be making use of this lab, Basic SSRF against another backend system. The reason why this lab is titled Another Backend System is because in previous labs, we've generated a server-side request forgery attack against the local host, making use of what is known as a loopback adapter. But of course, there could be a number of systems running on a specific network. And while it may be the case that some of those systems are not public-facing or internet-facing, in other words, we can't interact with them directly, it may be that if we can compromise a server on that network, we can use that server to send HTTP requests to those other systems on the network. That's what we're going to be doing today in this server-side request forgery lab. The vulnerability occurs when we make use of a stock check API. We click on a specific item, we have the ability to check the stock of that item. If we click check stock, we have burp running in the background. We're going to intercept this request to check the stock of this specific product. So we can see the HTTP request intercepted by burp. We see a post request to product stock, and we're going to send that request to the repeater. Taking a look at the body of this request, we see that it has a stock API argument as part of the body. It's URL encoded at the moment. If we decode the URL, we can see that the endpoint is product stock check, then it has some arguments after the query string. So the idea here is we submit a post request to the endpoint on the server, product stock. The server looks at that stock API value and sends its own HTTP request to the IP address 192.168.0.1, but we have the ability to change that URL. For example, we could simply change this to /admin, click apply changes, then click send, and we get a response from the server. Ultimately, this is designed to return some kind of stock count, and obviously the /admin is not going to do that. Now, we could of course continue to play around with this URL and the query string to see if we can get any results. But the purpose of this lab is to demonstrate how we can communicate with different hosts on the same network. And to help us do this, we're going to forward this request once again, this time to intruder. So we see our IP address here, 192.168.0.1. We're going to add payload markers around the last section of that IP address, and we're going to iterate over it with a series of numbers. We head to the payloads tab, we select payload type numbers, we're going to iterate from 1 to 256, and the interval is going to be 1 each time. Let's now choose start attack. Now we can see for the majority of these, we're getting a 500 response. We're interested in any status code that's not 500. And if we sort by status code, we see that we're actually getting a hit on 186. We have a response here. It's possible to render the response in burp. And what we see here is we actually have access to an admin panel. In other words, it's a different host on the same network. If we have a look at the request, we can see that this request is sent to the IP address 192.168.0.186. By iterating over the last section of that IP address, we've now been able to interact with another system on the same network. Ordinarily, probably can't access this system directly. It's not public facing, but we've manipulated the server into communicating with this particular endpoint. Now, checking out the render tab, we see we have access to an admin panel. The goal of this particular lab is to delete one of these two users. Let's just check out the lab guidelines. Use it to delete the user Carlos. Now, unfortunately, we can't simply just click on one of these options. Let's have a look at the HTML and let's have a look at the endpoint that's used to delete these users. So we want to delete Carlos. We can see there is an anchor tag there, we have an address 192.168.0.186 port 8080 /admin/delete. We then have a query string username equals Carlos. So we can't send this ourselves directly. We have to manipulate the server into sending this on our behalf. Obviously, if we try to send it directly, it's going to say, well, this doesn't come from a trusted source. In fact, we may not be able to send it directly anyway. We probably don't have access to this system. But even if we did, it's going to realize straight away that this comes from an untrusted source. We are forcing the server to send it on our behalf. This other system on the network at address 186 trusts this particular server. That's why it's called server-side request forgery. So let's copy this endpoint. Let's head back to our repeater. So here is our attack from earlier. Simply going to paste this new endpoint in. Okay, so we've pasted in our endpoint. Let's send this. Let's see what we get back as a result. We get a 302 response. Let's head back to our lab. If we scroll up, we get the message, congratulations, you solved the lab. So quick run through of what happened there. We sent a request to product stock. The server receives the HTTP request. It checks the body for the stock API argument. And the value it expects to see here is the endpoint on a different host on the same network that receives HTTP queries asking about the stock of certain products. The server takes that URL, it sends its own HTTP request to that endpoint, but we've actually hijacked that endpoint. We've now given this malicious URL instead. So the server sends a request to this URL, which just so happens to delete a user on the system. And the reason why that is trusted by the system at address 186 is simply because it originates with a trusted server. Of course, it didn't really originate with a trusted server. It originated with us, the attacker, because we were able to manipulate the HTTP request sent by the server by changing the value of this stock API argument. So one takeaway is anytime a server is sending HTTP requests in response to a HTTP request we've sent, it's not just that server that's vulnerable. The entire network is potentially vulnerable. If we can manipulate the HTTP requests being sent by the server, we can craft requests to be sent to any other system on the same network. All right, hope it was helpful. Thanks for watching.